Okay, Assalamualaikum and good morning, everyone. So we continue our manufacturing engineering class today with the topic of the SIM, Computer Integrated Manufacturing. So our content for this topic is product design and CAD. So we learn about the design processes, design process and application, and then computer-aided manufacturing, CAD, CAM, and computer integrated manufacturing. Then at the end of this class, the student should be able to understand and apply the concept of integrated manufacturing system. So the application here, so you need to have a capability to apply the concept what we will discuss about the integrated manufacturing later on, and then can be distinguished different concept in the integrated manufacturing. Should be distinguished different concept in the SIM. All right. So we go for product design and computer-aided design. So this is the critical function in the production system, critical function in the production system. So production system, we have we do the product design. So in the previous class, we have a requirement from the engineer, from the sales engineer. For example, we need to come out with the drawing for the product. So the product design engineer, they have a role to design the product and then to make sure the product can be manufactured based on their design. So they will pass the information. So you have learned the information flow from the business unit to R&D for product design, and then for the planning unit for production side. So the flow of information will pass over from product design is the what you call it, the design itself, the bill of material, the assembly drawing, the child drawing, the materials. So that is what the output of the product design. They need to have a good design. If the design is poor, if design poor, but the manufacturing, our manufacturing is very well. They have a sophisticated machine, 9 exist CMC machine, for example. They can produce the sophisticated machine part, but no meaning because they not contribute to the making the good product as well, because the design is very poor. But if the design is good, but the capability of the manufacturing, the machine side, the production side is not good, not sufficient enough, the capability of doing things, manufacturing things, so they also cannot contribute to the manufacture a good product as a sufficient low cost to contribute to the company profit as well. So that's why the good design and good manufacturing system or process, manufacturing process, remember, so we have several process together to make a production system. So this system need in good condition, in well managed to produce the part what we design. So there is a production, the production design, the rule and responsibility to make sure the product design can be manufactured. Design and manufacturing cannot be separate, each other. They come together in the production system, so they bound together as functionally technologically and economically. So they should come, the engineer inside both, in the production side and in the manufacturing side, should think, should have interaction with each other. Should think, should give the information to have the good product can be designed and then the good product can be manufactured. So the design process, so we already learned this one in the previous module, design and manufacture in the last year. So this one, I repeat again, the general design process, we have 6 methods. There is a conventional method. We need to recognize the need, the demand from the customer. We need to study the need, the demand based on what the problem they face and how to settle the problem. Do the synthesis, do analysis and optimization, and then come out with the prototype to evaluate and then do a presentation. And then we go one by one for this one. At the early stage, we need to find out the demand. So you have a task. For example, this year you need to do a group design project. So in the group design project, you have already titled what project you want to do. For example, in my group, they have a rifle, flexibility and compact rifle stand. So that is the requirement from the customer. So the demand there already. So they need the flexible stand, comfort stand. So we need to think the need, the problem what they have. So we need come out with the solution to them. So to identify the problems, the situation, we need to do a literature review. We need to do a market survey. We need to get customer feedback information. Why they need this one? Why they have a problem with the existing product? So that is all the information we need. We do a study based on competitor stand out there. We need to see what they have, what we can offer based on the requirement, based on the idea we have, based on the competitor, based on the market demand. So we can do a comparison. So they involve the realization by someone that problem exists in which some corrective action can be taken in the form of design solution. So maybe the problem highlight by from the existing one also, we can do a improvement. So improvement also the need, identify some deficiency in the current design, the weakness. So we need to find out how to solve that. So there is how we find out the idea or the need from the previous design to make a new design, or perceiving of some new product opportunity by salesperson. So when the salesperson come in with the idea, they discuss with the potential customer. The customer want to do a new product or new improvement in their factory. That is the needs, what the production side need to take attention to discuss on that, to pay attention and then to come out with the right drawing or right solution. So from the need, we go for problem definition. So problem definition always we do in group, the group of people. So you learn also concurrent engineering last time. So we need to do concurrently, parallelly, simultaneously with the others department as well. Production department, marketing department, engineering department, control department, to find out the solution from the problem. to define the problem. So same goes to your project for GMD, group for GDP, for group design project. You need to find out in your group to brainstorm the problem, definition, why and how to solve it, why this happened, how to solve, involved with the true specification, because you need to come out with the specification to lead you to design the product. From the need, you come out with the physical characteristic, for example, how big the product you want to design, what is the length, what is the width, what is the height, the weight, that is physical characteristic of your product. So you need to have the specification, and then the function, the cost, quality, the operating performance, how the product moves, how, what is the quality you target, and then the cost, how much you want to sell it, or to sell to the customer based on the market study, benchmarking. So that is all the specification you need to draft out, and then to get to the next stage, which is synthesis. So synthesis, analysis, and optimization always come together. So you have already specification, you already identified your spec. You have a several solution or concept from the problem definition. For example, you have several solution already. You need to compare those idea or concept to another to create the new idea or a better concept of the product. For example, you can see here in the synthesis, you have a parameter of the physical, for example, weight, height, tolerance here. And then you also have a cost, you also have a quality, you have also their function. So there is a variable or matrix parameters you want to control. You have this one. You put in system to do analysis based on this one. You compare with another concept. This one you compare using the computer system, for example. You come out with the 1 or 2 output from this one. From 4, you can have the best one, 2 or 1. So from here, you can do a analysis. You can do an analysis because analysis is from the best concept that you already decide from the synthesis. You do an analysis for their best performance. You find out, is it the weight or dimension or function given in the earlier version can get the best performance. You need to optimize them. That's why you do an analysis. That's why you do analysis. For synthesis, you can use a Pulse metric or another tools like QFD, for example, to find out the best concept from the synthesis. And then you do an analysis to find out the best performance or best concept. And then synthesis and analysis are closely related and interactive in design process. They are closely related. So you need to do synthesis and analysis again to find out the best performance. If not, you need to repeat again, synthesis, analysis, improve again, design, and then find out the best performance. And yet you will get the best design concept after that. So that is all optimization using the synthesis and analysis. You have a synthesis, you get the output here, using the output to here, and then to find out the best parameter or variable for the best performance. So maybe you decide the weight here, 4 kg. Maybe the best one is 4.1 or 4.2, we don't know. So that's why we do analysis to find the best parameter for the physical, the cost, the function, the appearance. So you do a analysis to find out the best performance and then to do the optimization. And then yet the second last is evaluation. Evaluation is to find out, is it the performance or the design is the best. So you can compare. You can compare with the physical, with the specification established in the earlier version, and then with the you can do a prototyping or fabricate prototyping or testing the prototype to find out to evaluate the performance, quality, reliability, and to find out the measurement item. So you can measure, you can make a comparison with the specification given. All right. And then you do a presentation. So compilation of the process design, you get the design, and then you do a assemblies, the child drawing, and then a specification given. So you can also have a database, and then you can have presentation in terms of report, in terms of data system to give to the production side. So there is a presentation. And then application computer in design is you need to use this computer system inside the process what I explained just now in the design. Typical design, they have analysis, synthesis, analysis, optimization, and presentation. There is 4 stages. Normally, we need a computer assist to make sure the can be effective design, can be reduce the time to make a modification of design, to do analysis of design, to do a documentation easily in terms of design. So reason to use CAD system, computer system inside design is to increase productivity, to improve the quality of design, to improve design documentation, and to create manufacturing database. So normally, like I said just now, when you use synthesis, analysis, and documentation using computer, we can reduce the time. So normally in manual, when we do a synthesis, analysis, repeat again, to find out the best optimization, and then do evaluation, do the drafting for presentation. So we need time, the time consuming. So when we use computer, this one can reduce. So we can increase our productivity in terms of design. And then quality also better because when we compile the analysis, when we design with the complete analysis, we can have better quality in terms of dimension. Also, we can get more accurate dimension. And then improve design documentation. So we can have better documentation of design, because when we do the manual drafting, we need to print, we need to draft, draw. So when we do computerized, we just print out the save in the floppy disk or in the drive to have a soft version. So we don't need to print out, we just email it and transfer the file to the production site, so we can have more accurate, more faster, and then more improving in the design documentation. And then to create the database also, we can create the production database, for example, to do in the computer-aided manufacturing. we can create the geometry or the coding to the specific product, components, design, material build. So when we do the manufacturing, we can just follow the manufacturing data, and then we can produce product with the specific machine, and then high quality, and then can produce in the lead in the time, in the quality given from the specification given. So design process can be simplified by this chart. So you can see here, this is typical one. Just now I explained to you. For the computer version, you can have support get computer aided design using geometric modeling for the synthesis, engineering analysis for the analysis and optimization, design review and evaluation for evaluation, and automatic drafting for the presentation. This is a computer version in design phase. So geometric modeling, I think you already learned in the SolidWorks. You have computer-aided design system to develop a mathematical model description of the geometry of the object. So to display image and model, so you can have this one, solid model, and also wire frame model. So you can zoom, you can see the actual, you can rotate this model to see the product. So to permit designer to design or construct a new model product, and then modify the existing product as well. So there is a geometric modeling. And then you do engineering analysis for the analysis, synthesis analysis, and optimization. You can use a computer. So they have several software for computer to perform the design analysis, like stress, strain calculation, heat transfer analysis, dynamic simulation, and also we have complex computational software like mass properties analysis, interface checking, tolerance analysis, finished element analysis, also called finished element modeling, kinematic and dynamic analysis. So you can see from this figure, this tooling part for do a temperature analysis of cutting tools using finished element analysis. So this is a cutting tool. So at this figure, you can see the knots using the finished element analysis knot. So you can see the knot when you do analysis. So they can show here. So there is how you can do can use the finished element modeling to do analysis, engineering analysis, and to do optimization. And then design review and evaluation to evaluate. Normally you can do prototype, right? And then to check the performance based on prototype you produce. But in the design review and evaluation using CAD, you have the checking, the automatic dimension, error checking, animation of discrete during the design process as well. So no need to do the evaluation at the end. So in the process, design process, you already do the evaluation to checking the design. So you can do the precision design, the dimension you design, and the accuracy of design. You can animate and then do a simulation of the design. So you can also do a prototyping, and then do evaluation, and then do a visual prototyping as well. So in the visual prototyping, you can do a mapping process, can rotate the part visually, and then can see the rotation, the part inside the visual. So this one you can do a visual evaluation, and then to find to compare the specification based on measurement what you have in terms of this station. So this one always time consuming. So if you can do during the design process, this one can do design during the design process, the evaluation with the prototype can do at the end. So you can save your design time. And then lastly is automatic drafting. For automated drafting, they need to come out with the printout version. For example, when you do manual drafting, you need to have a manual draft. You need to read, to assemble it based on drawings. So you have so many drawings, but when you use automatic drafting, you can reduce your time, and then paperless also. You can prepare high accuracy engineering drawing quickly, and then can transfer the CAD data to the manufacturing site to produce the part instantly and then accurately. And then introduction to computer integrated manufacturing. They encompass the entire range, of product development. So they cover all. They include all the product development or manufacturing activities in using the dedicated software. So the data required for various functions are passed from the application software to another software using the computer integrated manufacturing. So the term of computer integrated manufacturing sometimes used with the interchangeably used with the CAM or CAD-CAM. So they use computer control, and then computer-aided manufacturing is defined as an effective use of computer technology in manufacturing planning and control. So they use computer to cover everything. And then they have these several categories for planning, for example, manufacturing planning. They have computer process planning to plan, to make decision on production, process, machine tools, operate sequence, condition, work center required to produce the product and components. They refer for the planning. And then they have a computer assisted numerical control for part programming, efficiency for tooling, changing, programming inside, instruct the tooling changing, efficient method. They generate for NC machine to remove material using the specific tools. So they require the efficient tooling changing to do this task. Computer machinability data system, development of work standard and cost estimation, production and inventory planning. And then we also have a manufacturing control category. Manufacturing control category, they have a process monitoring and control, quality control, shop floor control, inventory control, and just-in-time production system. So this one also control using computer system, like I said just now in the previous chapter, to control the process in the manufacturing system. So the scope of SIM, they will cover all. Using the computer. So this is a scope of SIM. So this one I already explained to you just now. The information circulation from the business function to design to manufacturing planning, manufacturing control. They have circulate the information, and then from the design, manufacturing and manufacturing control, the scope for the using CAM, but for the SIM, they start from the ordering, the receive ordering until they produce the part and ship the part. So that is the scope of SIM. So computerized element of SIM system from the business function, they have ordering system, accounting, payroll, customer billing. For design, normally we use geometric modeling, engineering analysis, design review, evaluation, and automatic drafting. And then for the planning, we have cost estimation, computer-aided process planning, numerical control part planning, computerized work, capacity planning. And then for the CAM, we have process for control for the factory and operation floor. We have a process control, process monitoring, shop floor control. So this one is we call it also production system. Major element of the thing is we have 9 major element: marketing, product design, planning, purchasing, manufacturing, engineering, factory automation, hardware, warehouse management, finance, and information management. That is 9 elements in the SIM. So hardware, since hardware consists of the manufacturing equipment, we have such as CNC machine, robotic cells, the work handling, tooling device, sensor, so inspection machine. So there is a manufacturing equipment inside the production. So this is considered as a SIM hardware as well. But the part from the computers for the controllers, CAM system, workstation, terminal, data entry terminal, barcode, RFID, plotter, printer, modem, cable, that is considered computer hardware for the SIM as well. And then software, we have this kind of software to use in to run programming for the software based on the application. We have for the marketing, for the management information, ordering, inventory, manufacturing facilities, automation, material handling, ordering, engineering. So all this software will use based on the situation, based on the department or the part. So they work together with the hardware for the SIM, I explained before. And then how to be competitive in the global market. So manufacturing engineers are required to achieve the following objective to be competitive in the global market. So the engineer should think about the reduction of the inventory. So like I said just now, the inventory process is very important. So we need to keep how much the material need to order to keep, the cost of material, just-in-time system. So we need to think about the reduction of inventory. And then low cost of the product. So need to cut the cost, because when we design the low cost of the product, we can cut the cost in terms of the profit. We can increase. We can make more profit. Reduce the waste. Reduce the waste. When we do a material removing, for example, we need to have a good design to make sure the waste can be controlled. So can be recycled, for example. And then quality improvement, increase flexibility in manufacturing to achieve immediate and rapid response to the product changes, production changes, process changes, and then equipment itself. And then the quality function deployment, there is the concept or technique have been developed to aid the product design function. For example, they have several principles or methods of Taguchi, such as robust design, Taguchi loss function, can be applied to product design. So when we have this technique, we can eliminate the waste, for example. So when we have a design, we have use Taguchi loss function, for example, we have a graph. We have graph. We need to have optimize the design. So the part if not good, we can eliminate as well. We can have a good design only. So the concept you and the technique using the robust design and Taguchi loss function is very useful in terms of quality function deployment design. So QFD is a systematic for the organizing and managing any given design problem. So known as quality related technique. And then to design product that will satisfy and exceed customer requirement. And then this procedure, systematic procedure for defining customer desire and requirement. And then we need to interpreting them in terms of the product features and product characteristic as well. So these are the example, the technique we use in this figure. You can see that the customer requirement as an input, they have represent the metrics at the progression phase of the QFD analysis. So the customer requirement at the first will be translated to the product features as a technical requirement. They as an input, they translate to the technical requirement as product features. So they have several technical requirement, and then this requirement will give as an input to the next phase to find out the component characteristic. Component characteristic, also the product features. So this will be an output to the this process, but will be input for the next process, which is a process requirement. Process requirement is we need to find out the best how to conduct a manufacturing process to produce this design, for example. And the process, the sequence, the procedure. So this is a process requirement. We need to analyze, to plan, and then given as input to the quality procedure to find out the quality of the design. So the functionality, the appearance. So there is the input for this QFD, quality procedure. So this is can controlling the manufacturing operation. So general form for the QFD, you can see normally we can call this one also house of quality. So this one we have another section to discuss this topic. So in the quality, in the last chapter, I think. So together with the Taguchi method, robust design method. So we will discuss in that chapter in detail, but generally for this form for QFD, we have a section. We have 6 sections here. So as an input, come to the section 1 as a requirement. So there is a serve as driver for the current metric. So they have starting with this one. So if you don't have input, we cannot do another step. So this is a very important part. So have a section 1 is an input requirement. Section 2 is an output technical requirement. So we have several technical requirement as an output here. So in the section 3, we do technical correlation between each input here. So we do a mapping intercorrelation for the technical requirement in the section 2. So based on that, we can have a relationship metric in the section 4. So section 4 is the relationship metric. And then section 5, we do a comparative evaluation of our input. We need to compare our input requirement with our products, with the outside benchmarking customer. So we have a comparative evaluation of output of the input here. So in the section 6, we get our own requirement and output. So input, and then we have output here, output for our design. So comparative evaluation of output requirement. So that is how we use a general form, how we read the general form of QFD. So that is the normal one. We can have further discussion on that in the next chapter. So in the conclusion for this computer integrated manufacturing, we need to understand what it means in the manufacturing process using the SIM. What does SIM conceive? What the SIM can do? And then what is major element in the SIM we can explain. So all this one we already discussed. So I hope you can do a revision for this one, and then need to understand concept of design in beginning, and then after that, how we relate the design process using the computer integrated manufacturing. Okay, I think that's all our class today. Thank you very much. Assalamualaikum warahmatullahi wabarakatuh.